All right, moving to our next example as we talk about computing actual lengths from a scale drawing. So a graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. What will be the length and width of the tablet on the advertisement? All right, so here's what we want to do. We want to, again, set up that table. We're used to finding constants and all that stuff. Scale factor is another constant. Unit rate. We do it from a table. So that's where my comfort level is. So it's probably not, I know it's not the only way to do it, but that's where my comfort level is. So if I look here, I'm going to say this is my drawing. In this case, picture. Okay, picture drawing. And we put the actual. Again, picture drawing actual. And then I want you to write the scale. Okay, our scale is 0.25 inches to 1 inch. All right, so when I do that, this makes it easy to be able to find the constant, and the constant is the scale factor. So you might be able to look at this and you might know what we have to do right away, but if not, remember we find our constant by going y divided by x. Also our scale factor. So I am going to go 1 inch divided by 0.25. And if you were to grab a calculator and figure that out, maybe I can grab mine real quick here. You get 4. Now we could do the fraction operations. We could have done all that. We get 4. Okay, so our scale factor is 4. That means this times 4. Now I can use these two lengths here. Length. And it doesn't matter which one you say is the length and which one you say is the width. Let's see. I will say this is my length, 1 1/8 of an inch, and this is my width, 1 1/4. And what I'm going to do is I'm going to multiply that by my scale factor. Times 4 times 4. Now, these, because they're fractions, we're going to do some fraction operations. So I'll just come over here. 1 1/8 times 4. Well, remember, if we're doing any multiplying or dividing with mixed numbers, we have to change them in improper fractions. So 8 times 1 is 8 plus 1 is 9. So this is 9/8 times 4 over 1. You can multiply straight across. You can pull out common factors. Well, you only have a common factor of 1, doesn't do anything, but 4 and 8, 4 goes into itself 1 time, 4 goes into 8 2 times. We get 9 over 2, which is 4 1/2. 2 goes into 9 4 times. That'd be 8. I'm left with 1 of the 2 left over. So the length here is going to correspond to 4 1/2 inches. Okay, and I can do the same thing here for the width. I'm going to take 1 1/2 and times it by 4. That's not right. It's 1 1/4. So, improper fraction. 4 times 1 is 4, plus 1 is 5, so that's 5/4 times 4 over 1. 5 and 1 have a common factor of 1. 4 and 4, though. 4 goes into itself 1 time, 4 goes into itself 1 time. I got a whole bunch of these 1s here. 5 times 1 is 1, 1 times 1 is 1. This works out to be 5 inches. Okay. So if you can find the scale factor, which is the constant, and we always set it up as drawing actual, we can figure out what our actual length and width on the advertisement. One question that's not on here, but I want you guys to be aware of for your homework, is when it says, you want to question homework, what shape will it be? So if this is the scale picture of the tablet, when we enlarge it, because it's going to be an enlargement, I believe. Yep, she needs to enlarge it. What shape will it be? I'm really scribbling now, right? And the reason I point this out is we just make this bigger, right? is it going to change its shape? Is it going to go from this rectangle-ish figure to a triangle? No. And so keep in mind that when you're doing your homework, that when we're enlarging or reducing, the shape is staying the same. It's rectangle in my sloppiness. Okay, let's look at one more example using, again, the idea of the scale factor, which is our constant, to find actual lengths. All right, so a lot of words here. It can be intimidating. So basically, you can read through this, but what it's saying is there's students from this high school that are going to go to the atrium, like the center section in the mall, and they want to perform their acts from one of their musicals. So they want to bring some information with them. They want to bring some of their set with them, so they can, kind of show off. So the backdrop they want to bring has panels that measure 10 feet by 10 feet. And they're not sure if those panels can fit because they have to be transported flat. They can't turn them or anything. So I have the sense of panels need to be transported flat, horizontal. All right, so here's the mall floor plan, and we want to know, can they fit through this entrance here? That's what we're wondering. Are they going to be able to fit through there? Well, 3/8 of an inch doesn't tell us much. What is that actually? So again, set up your T-chart and write down your scale. So I'm going to just kind of scroll back and forth. I'm going to do that right here because there's some room right here. All right, so setting up my T-chart. We have our drawing, our map, whatever. Drawing first, actual second. Okay, because what are we doing to the drawing? What are we multiplying by to get our actual length? And then we start, remember, with our scale first. So I come up here, somewhere on these maps, I'll show a scale. 1 inch, 1/8 of an inch, represents 4.5 feet of actual length. So 1/8 of an inch is 4.5 feet of actual length. So remember, this is our x and this is our y. And if I want to find my scale factor, I am going to go k equals y divided by x. So I'm going to take my actual 4.5 feet and I'm going to divide it by my scale, 1/8 of an inch. So change it in improper fraction. 2 times 4 is 8, plus 1 is 9. So this is 9/2 divided by 1/8. Keep it. Switch it. Flip it. Multiply straight across, or you can cross reduce. 9 and 1 have a common factor of 1. 8 and 2, though, 2 goes into itself 1 time, 2 goes into 8 4 times. I get 9 times 4, which is 36, and 1 times 1, which is 1. Okay, so we get 36 here. Erase that because I just want some room. Okay, so I'm going to actually jump down here to part B. What is the scale factor? Well, the scale factor is 36. What does it tell us to do? Well, it tells us to multiply the drawing lengths, but I'm going to say the drawing, by 36 to get actual measurements. Okay? Times 36. So now we're focusing right now on the mall entrance. So really, our mall entrance is all we're interested in. We don't need any of the other things. So I'm going to take my 3/8 of an inch right here and see if that works. So 3/8, what does that correspond to? Well, let's figure it out. All right, so I should have left more room. Sorry. Let's make that shorter. Okay. So I'm going to take 3/8 and I'm going to multiply it by 36 over 1. 3 and 1 have a common factor of 1. 8 and 36. Well, 4 goes into 8 2 times. 4 goes into 36 9 times. And I'm left with 27 over 2. Now on a calculator, it's 13 and a half. So maybe you know what that means as a fraction. I could say that 2 goes into 27 13 times. That's 26. So there's 1/2 left over. Okay, so 13 and a half feet. So on the drawing, it's 3/8 of an inch. That corresponds to 13 and a half feet. So if they're 10 by 10, can we fit that in 13 and a half feet? Yes, they will fit. Yes, we'll say we have 13 and a half feet available. I don't know, something like that. All right, the main key takeaway I want you to take away from this is notice, set up your T-chart. Always drawing, then actual. That's what we're going to go with going forward now. And then if you do that, you can find your scale factor. And your scale factor, we can use that to find the actual measurements when we're given the measurements on a scale drawing.